Hi, hello guys, welcome to my another video. This is Darshan explaining about introduction to antenna and wave propagation by using the integral calculus. This is the topic related to mathematics. Let's know about an antenna. Antenna is an electrical component in a wireless communication system, enabling the transmission and reception of an electromagnetic wave, where the wave propagation describes how the wave travels through various mediums, a fundamental concept in an antenna designing and analyzing. Let's move to the next slide. Coming to the fundamental concepts of electromagnetic waves. Electromagnetic wave consists of an oscillating electric and magnetic field that propagates through the space and speed of a light. Means electromagnetic waves are converted or formed when in presence of electric and magnetic field through a particular space with the speed of light. These waves consist of an or described by a wavelength, frequency, and amplitude, which are related to the fundamental equations in physics. Antenna and wave designing related to an understanding of polarization, reflection, and interference of those waves as they are interacted with the environment. Moving further, radiation pattern and diversity. Radiation pattern. The radiation pattern of an antenna describes the distribution of radial energy in a surrounding space. It's crucial parameters that determine the coverage area of an on performance of an antenna. Directivity. Directivity is a measurement of how much the antenna concentrates the radiation power in a specific direction. Higher directivity antennas can focus energy in a narrow beam, improving the range of signal strength. Means it's talking about the radiations and the direction here. The radiation pattern, which require an energy, surrounding which it helps the energy helps to provide the radiation from one pole to another pole in its surroundings, that too in a circumference path. But in the directive part, which they can provide a powerful radio wave in a particular direction, which makes a narrow beam, which increases the range of the signals or the radial connections. Going further into radial intensities. The radial intensities is a power radiation from the antenna per unit solid angle. It's important factors in determining the antennas and directionality and gain. Moving into the further slide, integral calculus in the antenna theory, which we are going into depth of the integral calculus, which is involved in an antenna. Integral calculus plays a crucial role in antenna theory, allowing the engineer to modify the complex electromagnetic wave and energy flows surrounding the antenna. This magnetic approach helps to optimize the antenna designing and predict the radial pattern and analyze the impedance matching for the effective power transmission. As you can see here, let me take here. This mathematical approach helps the optimizing antenna design. Means this helps in designing the antenna's shape and size, predicting the radial pattern. Means it helps in prediction of radio waves which are already passed, and analyzing the impedance. Here the impedance means the opposing electric current or the electric function which is going on. That it helps in matching it and confirming the electric power transmission. By integrating field equation over the antenna's surface and volume, engineers can calculate the key performance of a meter-like directivity. Means by these calculations, they can make sure that the performance or the radial waves which are emitting that can give this much of measurement through the radial signals, as you can see here. And the directivity, gain, and efficiency. Integral calculus also enables the analyzing of antenna array where the constructive and destructive interference of individual elements is crucial. Going to one of the further slides. Impedance matching and Smith charts. Impedance matching is crucial in antenna designing the maximum power transmission of minimum reflections. The Smith chart a graphical tool that allows the visualization and analysis of a complex impedance, enabling the engineer to design a matching network for an optimizing performance. This impedance matching and Smith chart helps in reflecting of an optical waves or an radiations through a wire, which helps in matching the networks, helping the users and the engineers more effectively. By understanding this principle of smooth chart and analyzing the antenna designing can prescribably match the input impedance of an antenna to the characteristics impedance of a transmission line, ensuring the effective energy transmission of a minimum signal loss. Once it ensures that the minimum energy loss from the transfer of minimum signal. Coming to the propagation models and the path loss. Free space path loss describes the power loss of an electromagnetic wave as in propagated through a free space without an obstacles. This model is used for line of slide synovance. Humoral Hart model, an empirical model that accounts for an propagation in urban, suburban, and a rural environment. It consists of factors like an frequency, antenna height, and a distance, shadowing and fading. Obstacles and terrestrial can cause an signal shutting down, leading to an unpredictable power fluctuations. Fading model like reliance helps in predicting this effect. Means by this are the two devices which are already installed on antenna helps in predicting the obstacles or the terrestrial causes that may cause this shutdown of signals or the prediction of power fluctuations. Coming to the path loss exponentials, these are the empirical exponential describing the rate of signal decline with a distance. They are various based on the environmental and being used by estimated path loss. Fading and multipath effects. Fading. A radio signal can experience a fade due to the obstacle, interference, and distance from a transmission. Means this can result in a fluctuation of signals and strength, leading to a discouragement of performance. Means the older days, the interference of particles in between the transmission and the receiver that may cause to degradance of performance. Means there would be no message conveyed properly, or it would be an unhappy for customers. But in this multipath, the signals can be bounced off buildings, mountains, and other objects, creating the multipath from transmitters and receivers. Means the multipath bounces off the buildings and mountains, which helps in proper signal connections. This multipath inference in can cause and destructive signals, cancelling the disruptors. Means this may interfere in destructive signals. Means there will be no proper continuous signal passage. There will be a breakdown of signals at sometimes. Measurements. Engineers use an advanced signal analyzing tools to measure and characterize the fading and multipath effects, allowing them to design and rebush communication system that is migratable those challenges. This measurement helps the engineers to clarify the signal from where the radiation which is passed from the main city or the main point to the required point of the customer, which helps in providing a proper measurement or a proper clearance of the data or an information of network. Going further, we have antenna design using an integral calculus. In that, we are going to study about integral calculus in foundation. Integral calculus provides a powerful mathematical framework for modeling and analyzing the antenna behavior. It enables the calculation of radiation path, impedance, and the other key parameters, estimating the effective antenna design. This helps means the radiation pattern, impedance, and the parameters which is taken into consideration for designing the antenna, which makes an effective one to get a more efficiency from the antennas their works. Antenna designing with the help of geometrical analysis. By applying the integral calculus for the complex geometries of antenna, engineers can optimize the shapes, size, and desired radiation characteristics such as deviating and gain. As in said in the further before slides, this helps in radiation characteristics and deviating and gain. These are the This deviating and gain are the technical terms which were used by the engineers. Now coming to the field current and distribution. Field distribution and current distribution. Integral calculus are used for determining the distribution of electromagnetic field and current along the antenna structure, allowing the prescribed turning and matching to the desired applications. Moving further, we are going to deal about the Impedance modeling. Integral calculus enables the accurate modeling of an antenna impedance, which is critical for minimizing the reflections and ensuring the effective power transfer from the transmitter to the antenna. Applications of antenna and wave propagation. Satellite communications. And wave propagations are the fundamental to the satellite-based communication, enabling the global connections and the data transfer from the vast distances. Going to the cellular network. Cellular tower lines leverage advances the antenna design and propagation models to provide a semi seamless seamless mobile coverage and high-speed wireless access. Going on to the radar and sensors. Radar and sensor applications rely on an antenna array and a wave propagation principle to detect, track, and map a wide range of targets. Radio astronomy. Radio telescope and their specified antennas enables the study of celestial bodies and the phenomena detected in analyzing the faintest radio waves. At last, coming to the conclusion of the future trends. As the conclusion of exploring the antenna and wave propositions, we look ahead for executing and future for dynamic fields, involuntary of material signal processing and computing methods in a drive breakthrough in an antenna design and waveless communication.